Hello, this is a contribution from Kuzu Console to the Algorand ecosystem by Stephen Sunday and Seth Michael. In this presentation, we'll learn how to develop a decentralized application in the form of a web app using the .NET Core framework to develop an automated payment system on the Algorand network. So right here, I have my Visual Studio 2019 open. I'm going to go ahead and create a new project. We will then be prompted to this window where we can select or create the type of application we want to create. Head over to the search bar here and click on API and type in API because we want to create an ASP.NET Core Web API application with the C# language. So click on this with the C# language right here. Mind you, this is for F#, but we want to create an ASP.NET Core Web API with the C# language. So click on it and click on next. So we will then be prompted to this window right here where we can configure our projects. We can select or choose the project name. We can select the location of the project and the solution name that will be attached to it. So go ahead and configure that and click on next. So the last step is for us to select our target framework, the authentication type, and additional options attached to it, which is titled here additional information. We're going to go with the current version of the .NET Core, which is the .NET 5. So go ahead and select .NET 5, leave the authentication as none, click on the configure for HTTPS checkbox, and then also click on the enable open API support. So you can leave every other thing as it is by default. No need for Docker, just leave that out, and just the way it is right here. Go ahead and select the options that we have and then click on create. Okay, so our project has created successfully. So the first thing we're going to want to do is to install the necessary dependencies and packages needed for us to run an automated payment system on the Algorand network. So the first thing we're going to want to do is head over to dependencies, right click on it and click on manage NuGet packages right here. Okay, so right here we have installed the necessary packages that we need. So I'm going to go ahead and show us the packages needed. So the first thing is to install the Algorand package itself. So we're going to head over to browse and search for the package name right here. For example, we want to install the Algorand package. We can type in Algorand right here and then we'll be shown the package for us to install, but I've already installed the package, so no need to do it again. Head back to install. Upon doing that, we can see the packages that I have installed for this demo purpose. You can see the Algorand package, the Hangfire.ASP.NET Core package, the Hangfire.dashboard.basic.authentication package, the Hangfire.memory storage package, the Hangfire.SQL server package, and then the Swashbuckle.ASP.NET Core will be automatically created or installed into our application upon creating an ASP.NET Core Web API project. So having done this, the next thing we're going to do, we're going to create a folder containing our services, which we're going to make use of to implement our automated payments. Okay, so we have created the services folder containing our iPayment service, an interface, and a payment service, which is a class. So inside of our iPayment service, we have our methods right here. It asks for one-time payments and it asks for group payments. So we're going to implement this method inside of our payments class. So to do that, go ahead and navigate to the payment service class and inherit from the iPayment service. So go ahead and inherit from the iPayment service, and then we'll be prompted to fix this. So go ahead and hover over it and click on the show potential fixes. Do that and then implement the interface itself. So click on this option to implement the interface. Okay, so we have successfully implemented the interface and our error has gone. So we can see the methods right here, which is for group payments and for one-time payments. So the group payment is also known as the atomic payments, whereby we can, or atomic transactions, whereby we can fund multiple accounts at the same time, whereby the one-time payment is a one-time transaction where we can fund or make transactions on the Algorand network on a one-time basis. Okay, so the first thing I'm going to want to do here is I'm going to remove out all the namespaces that I don't need at the moment. So, and then I'm going to go ahead and paste in these namespaces for the Algorand network, which we are going to paste in the codes later on in the next step. So these are the namespaces we're going to need. So I've pasted it right here. We have the Algorand, the accounts equals Algorand.account, the Algorand.v2 because we're using the version 2 of the Algorand. We have the Algorand.client, and then we have the Algorand.v2.model. Okay, so inside of the group payments, I'm going to go ahead and cut this out and then paste in the following code snippets that we have here. So I'm going to go ahead and go back to the top. So I'm going to make this async so we can avoid this error. So the first thing that we have here is our Algorand API address running on the PureStick version 2, that is PureStick 2. And then we also have the Algorand API token. So we have the address and we have the token. So then we have our source accounts. I'm going to pull up a link in the next step to show us how we can generate an account address and a mnemonic key attached to the account address. So this is a source account. This is a mnemonic key for the master account because we're going to have two or three accounts that we're going to make use of during the course of this tutorial. So we have this particular account address, account key rather, which we'll then use to fund other accounts during the course of the group transaction, because we're going to make transactions or send algos to two accounts addresses, which is a group transaction, because we're grouping the transaction and then making transactions with the account addresses that we grouped. So we have a master account, and this is the account key or the mnemonic key of the master account, which we are going to make use of to fund the other accounts. And the other accounts, we have a destination account here, and then we have a destination address rather, which this is the address, and then we have the second destination address, and this is the address also. So we have two addresses here that we're going to fund from the source account, that is the master account. So we have an account class here, which we made an instance of, passing in our account source, which is the mnemonic key right here. Mind you, mnemonic keys are meant to be private and not shown to the public, but because this is for demo purposes, and in case you haven't seen a mnemonic key or you don't know how a mnemonic key looks like, this is how a mnemonic key looks like. A combination, a collection of words forming up a mnemonic key. So that is what our source address is containing, and with a mnemonic key you can make transactions. So try as much as possible to keep your mnemonic key private to yourself, because if someone else has access to it, that person can perform transactions with your account, from your account, to fund other accounts or make transactions to other account addresses. So we have a variable for Algorand API instance, passing in our Algorand API address and our Algorand API token into the Algorand API method right here. So we can see it. If you hover over it, you can see a brief description of what it has. We have a string host and a string token. So this is the address as the host, and then this is the token. So we then have our Algorand that making use of the v2. We do not really need to make use of it since we have declared it above. So we can just make use of the transaction parameters response, making a transaction params. Okay, so we are not assigning anything to the transaction params yet. So then in the next step, we have a try and catch exception error handling, just in case we come across an exception or an error. So inside the try, this is where we're making use of the params, passing in the Algorand API instance transaction params. The transaction params is a built-in function. Because we made use of our Algorand API instance from our Algorand API method right here, class rather, we then have access. This Algorand API instance has access to everything or every method that is inside the Algorand API class, which is why we were able to call our transaction params from our Algorand API instance, because the Algorand API instance has access to all the other methods inside the Algorand API. So we then have a catch exception, making use of our API exception just in case we come across an exception. So we're going to catch the exception and then show could not get params attached to it. So the next step, we have a variable for amounts, passing in utils.algos to microalgos. Okay, so in this group transaction, we're going to fund one algos to each of the account addresses that we have. That is the destination address and the destination address 2. So we're going to fund them one algos each to those account addresses. So which is why we have one right here, passing in one inside of here. So we then have a variable for transaction. This is tx for transaction, making use of the utils.getPayment transaction. So this is a process that is going to perform the whole payment system on the Algorand network. So if you hover over the get payment transaction, we can see some details about it. So we can see address from, address to, an unsigned long variable containing our amounts, and a string message, and then our transaction parameter response for our transparams. So that is what we have here. We have our source.address, that's the src.address. Okay, that is the account we are sending from. And then we have a new address, destination address, that is the address we are sending to based on what we have. And then we have the amounts, and then a message. This amount is the amount that we declared right here for one algos. And then we have lastly the transaction params. So we have the same thing again for transaction, our second transaction, but then we are sending it, grouping it. This is the second account address we are finding, which is destination address 2. So down below we have our digest, the GID in short, making use of our transaction group.compute group ID. So this is going to group our transactions, our first transaction and our second transaction, which is TX here and TX2. So it's going to group them and then perform an atomic transaction with them. So we then have tx.assign group ID, making use of the GID that we have here, and then the same thing for the second one, transaction 2, which is tx2 dot assign group ID, passing in the GID we have here because this is responsible for grouping them up. So then we have our sign transaction, making use of our source.sign transaction for the first transaction that we have, and then we also have the same thing for the second transaction. All right, so we go below, and then we have a try and catch exception also, and then I'm going to go ahead and import the using namespace needed for our list to work. So hover over it and click on show potential fixes, and then we will then import the namespace that we're going to need. So go ahead and import the using system.collections.generic. Go ahead and click on it and our error should be gone. So yeah, we have it. So you can go back up and double check. You can see the namespace we just imported. So back here we have a list of bytes. All right, that is a bytes list. We have a byte list here, passing in our algorand.encoder.encode to message pack, passing in our sign transaction. So this is for the first sign transaction. Okay, so we then have a byte list, which is this byte list we created right here. This is an object of our list here. So byte list.addRange, we're then going to pass in our algorand.encoder.encode message pack for the second transaction then. So we have for the first one, and then we have for the second one. So we have a variable ID, making use of our Algorand API instance.raw transaction containing our byte list dot to array. So we're going to convert it to an array. All right, so we then have a successful send transaction message with the ID of the transaction. So down below we have the round of the particular transaction, the round where the transaction belongs to, which is making use of the utils with transaction to complete. So this is going to wait for the transaction to complete before doing any other thing else. So we then passing in our Algorand API instance and our ID.transaction ID, okay, and then dot confirmed round. So lastly, we have a catch exception. So should in case we come across an API exception error, it is going to catch the error and then display the following message that we have here. So for the one-time payment, I'm also going to go ahead and cut this out and then pasting the implementation. So back at the top, I'm going to make this asynchronous, just the way we did with the previous one. So we have our Algorand API address and token, our source, and our destination address, just like we explained earlier on. We then have our Algorand API instance passing the Algorand API address and token. We then have a variable containing a variable called trans, or transaction, containing our Algorand API instance transaction params in a try and catch exception, should in case we come across an exception error. So we then have our transaction parameter response, making use of it right here, just the way we did for the group transaction. So everything here is pretty much a repetition of what we have in the group payments, just that this is a one-time payment, so we do not need that whole grouping procedure. So we then have a variable containing the amount we're going to send. For the single transaction, this is a one-time payment, we're going to fund or send 2 algos to the destination address. Okay, right here. So we have our source address, destination address, we have the amount sent, the message, and then the transaction params, just like we had above up there. We have our signed transaction, we have our message containing the transaction ID. We then have a try and catch exception error. We then, inside of it, we have our ID, variable ID containing our utils.submit transactions, passing in the Algorand API instance, and then the signed transaction that we declared right here, containing the signed transaction for our transaction TX, which is here. So having done that, we then have a console.writeLine, which is going to print out a successful transaction, passing in the transaction ID also attached to it, concatenating it right here. So the next step is to wait for the transaction to complete, passing in the Algorand API instance and the ID of that transaction. And then finally, we have a catch exception, should in case you come across an API exception error during the procedure or process of performing this one-time payment transaction on the Algorand network. Okay, so the next thing we're going to have, we're going to create a class called job. This is going to handle the job processing as we perform our automated payment system. We're going to call it job because when dealing with automated system, it has to have something to do, which is a job, which is why we're calling it a job. So I'm going to go ahead and create a job class in the next step as we proceed. So right here, I've created the job class. You can see it here in the project files. Go ahead and click on it. We can see the class right here for the job. So I'm going to go ahead and paste in the code snippet we're going to make use of. So we have our private read-only containing our iPayment service that we created inside of our services. So I'm going to go ahead and hover over it and add the namespace attached to it. So go ahead and do that. Click and add the namespace needed. I don't need these other namespaces, so I'm going to go ahead and clean them out. So we'll be left with just those 2. So here I have a constructor of my class job passing in the payment services, our payment service rather, for iPayments. So making use of the payments here, passing in the parameters that we have here. So inside of the methods, we have a one-time payment job async, and then a group payments. I'm also going to make this job async. Okay, so inside of the one-time payment job async, we have a variable for results, making use of the payments dot one-time payments, because our payments here is having access to everything containing inside of our iPayment service. So we then have access to the one-time payments. Just if you go back into the iPayment service, we can see the one-time payments, and then we can see the group payments, which is what we're making use of here. So payments, the one-time payments, and then for the group transaction also, for the group payments, we have payments.group payments. So having done this, we can proceed to the next step. So in the next step, I'm going to show us how to create a database, because we're going to make use of an existing database during the course of this tutorial, so we can connect to our Hangfire, and then the Hangfire can have access to our database for it to run on the server. So head over to the Server Explorer. Go ahead and click on this Connect to Database. Okay, we'll be shown this short mini window. So leave everything that is here by default, and then inside of the server name, go ahead and paste this out, the local db in bracket / we have our MS SQL's local db. So go ahead and type this out also, and then enter the database name you want to use. So I'm going to use the automated payments Algorand, just like we have on our solution name. Okay, having done this, go ahead and click on OK. So we can see a mini window right here saying the database automated payments Algorand does not exist, or you do not have permission to see it. Would you like to attempt to create it? So we're going to select the yes, because we want to create the database since it does not exist. So go ahead and click on yes, select the yes, and then this will create the database for us. Okay, so having done this, let's head over to the SQL Server Object Explorer. I'm going to go ahead and refresh this. Click on database, and then we can see our database right here, our automated payments Algorand. As it is now, the tables are empty. We do not have anything in it just yet. So having done that, head over to the app settings.json file, and then add the following code snippet that we can see here: the connection string containing mycon, which is going to pass in our connection string of our database. So to do that, head back to the SQL Server Explorer on our automated payment Algorand database. Head over to the properties. So we can see the properties right here at the lower right corner of the screen. So go ahead and scroll down to find the connection string. So we can see the connection string right here. Go ahead and copy it, and then paste it right here. So we then have our connection string. We can see our catalog, which is the database name automated payments Algorand, which is correct. So having done that, the next thing we're going to want to do is to configure our startup class. So let's head over to our startup.cs. So inside of the startup class, we just made some adjustments or changes to it. We added this private static iPayment service from our iPayment service interface, passing in our payment service object to it. We then have a private read-only, making instance of our job class, passing the payment service we have in it, and then the object name for this is our job scheduler. So the second thing we then changed was a configuration inside of our services, our configuration services. So we then added a region for configure Hangfire. This is going to configure our Hangfire in addition to the database that our Hangfire server is going to connect with. So we then have services that add Hangfire, passing in our c.use SQL server as our SQL server containing our configuration string for my connection from our database, which we declared earlier on as mycon, which is my connection in short, which is what we have over there. And then we also have another with our global configuration, that's global configuration that use SQL Server storage. We're also passing in the get connection string, which is mycon, but then this is with job expiration timeout, so it's going to expire our timeout after a time span of 7 days. So, and then lastly, in the services, we have our services that are transient, passing now iPayment and then our payment service. So if we hover over the transient, we can see it returns a reference to this instance after the operation has been completed. So in brief, it transient service of the type specified in the iPayment service with an implementation type specified of our payment service. So which is what we just did right here. So inside of the configure method that we have here, we also added our iBackground job clients and our iRecurring job manager. Okay, so this is for our background job clients, and then this is for our recurring job manager. Should in case you want to perform tasks or jobs that are going to reoccur several times. So the next thing we then configured was our region for our configuration of Hangfire, making use of our app.use Hangfire server, and then we then have a basic authentication added to access the Hangfire dashboard. So from our dashboard, we're able to keep track of our automated payments. So we then have our app.use Hangfire dashboard. We have our routes, that is /Hangfire from our dashboard. We then have an authorization right here. So we're then going to have credentials, that is a username and our password for the authentication for a user to be able to access the Hangfire dashboard. So to be able to do this, let's head over to our app.json section, and then just under allowed host, you can put it anywhere within the curly brackets there. So I'm going to add this, which is our Hangfire credentials. We have our username, which is admin, and then our password, which is admin at 123. So go ahead and add this, and then let's head back to our startup class. So that is it with the configuration of the basic authentication about it. And then lastly, we're then going to make use of our this is what is going to process the jobs or the scheduled payments. So we then have a recurring job manager that add or updates. We can see a brief explanation here. We said recurring one-time payment job for every 5 minutes. So after every 5 minutes, our one-time payment is going to process. So we can see insert task runs every 5 minutes, and then we passing in our job scheduler containing our one-time payment job async. Okay, we can see it here, and then we then have the next one for our group payments job async, which is recurring atomic transfer job for every 5 minutes. So after every 5 minutes, this is going to perform or process, which is for the group payments also. And then we then have a fire and forget job. So for the fire and forget job, this works when we launch the application. The payment is going to run once, which is the fire and forget. It's going to run once and then forget about the job. Unlike the previous two that we have here, every 5 minutes is going to run. This will run once and forget about the job. So we then have a scheduled job or delayed job, whichever one you decide to call it among the two. So this is going to work in a scheduled way. Okay, so we can pass in the number of, or the time span, or the number of days we want this job to run. So we're scheduling it to run from a time span of 29 days. So after every 29 days, this particular job is going to process. So should in case you have employees you want to pay, and then you don't want to necessarily go in and then start paying them in algos manually, you can set the scheduled payment timer. So after every 29 days, which is month end approximately, we can then proceed. The application will then proceed to send or fund them the algos to their account addresses without you having to click any button or send anything manually. So the next thing we're going to want to do before we launch the application, we're going to want to fund the accounts. That's the master account address that we're going to use to fund other account addresses, either via the group transaction or the one-time payment transaction. So to be able to fund the account address, we're going to make use of a tool that we can use to fund the account address, which is the bank.testnet.algorand.network on the Algorand network running on the testnet. So to do that, I have some tabs open on my browser. So this is testnet.algoexplorer.io. This can be used to keep track of the transactions that have been done with the account address. and the other account addresses. So this is the account address for the master account that we're going to make use of to fund other account addresses. As you can see at the moment, the balances here is 1.9 algos, and then we then have another one. This is a destination address, and then this is another destination address. So these two account addresses are the destination addresses we're going to use the master account, which is this, to fund them. So we're going to use this particular master account to fund this account address and this account address. So to be able to do that, we have to first of all fund this account address so we can have sufficient balance to be able to make the transactions work. So to do that, head over to the Algorand dispenser, which is running on the bank.testnet.algorand.network. Go ahead and click on the checkbox for I am not a robot and then complete the challenge. So having done that, go ahead and paste in the account address, the account address rather. So I'm going to go ahead and copy it and then head back here and then paste in the account address. Having done that, hit on the dispense button. This is going to dispense algos, about 10 algos to the account address. So we can see a code status of 200, which means success. That means we have successfully funded the account address. So if we head back here, we can see our new balance now is 11.98 algos. So we were successfully funded 10 algos on this account address. And then mind you, this is running on the testnet, so we can see our testnet here. We can see the options here: mainnet, testnet, and betternet. But we are running our transaction on the testnet, so no real transactions are being made actually, because this is on the testnet network. So having done this, we have successfully funded the account address. We can go ahead and do that again, and then click on the challenge and do it. So we can then paste in the account address again and then dispense funds to it. So we should have about 21 algos here. So we can see it has updated successfully about 8 seconds ago. We have successfully funded the account address. So now we can launch the application and run our automated payments. So back in our application, let's head over to debug and then click on start without debugging to launch the application. So while we wait for the application to launch, let's keep track of our balances here. The master account address has about 21 algos. One of the destination addresses has about 10 algos, and then the other account address has about 8 algos. So let's keep track of these two destination addresses, the one with 10 and the one with 8 algos, while we wait for our application to launch. Okay, so our application is up and running while we wait for it to finish loading. Okay, so our server is up and running, and I just navigated to the Hangfire route, and then I'm being requested to enter the username and password for the basic authentication by Hangfire. So I'm going to enter the username, which is admin, and then I'm also going to enter the password, which is admin at 123. So go ahead and do this. Okay, so we can see our server is up and running, connected to our database. It was started about 3 minutes ago, and then we can see our recurring jobs. We can see this recurring job for the group payments job async, which was created about 3 minutes ago also when the server started, and then the next execution is about 3 minutes, next execution a few seconds ago rather. So if I head back to jobs, or if I head over to jobs, I can see our scheduled jobs. This is for the group payments job async, which is going to run or enqueue in a month time. So after about 29 days or so, this is going to perform. So we can see some jobs have already been processed and have succeeded. So I'm pretty sure which is is the fire and forget, and also the group payment transaction job async. So we can see them here. This one succeeded in about a minute ago, and then this one in about 4 minutes ago. So the one-time payment job async. This is for fire and forget, and then we can also click on it actually and see a little bit more details about it. Okay, so if I go back, I can see them. So we can see the group payments job async. I can see the one-time payment job async. So this group payment job async, we just succeeded in about a minute ago. It's under our NQ, or recurring jobs rather. So it's going to recur continuously and run continuously. So this was created 5 minutes ago by now, and then the next execution is in 3 minutes ago. Is in 3 minutes time rather. So we can see how it works. I do not have to click any button to make any transaction by just starting up the server or the application. Automated payments will process. So if I head back over here into the account addresses, so we can see once it was 8 algos, but now we can see 9, which means the group transaction worked. So if we head over here also, we should be able to see the newly updated balance for the account address. So we can see it here. So it was 10 that we had here, about 10 algos, and then we had an atomic transaction for the 2 of them here, and the atomic transaction was supposed to transfer 1 algos to each account. So this one has gotten its 1 algos, making it 9 in total, and then this one had 10 algos. Because of the 1 for the group transaction, it made it 11. But then this particular one also has a one-time payment which also succeeded from our recurring jobs. So if you head over to jobs and then succeeded, we can see it right here, group payments and one-time payments, which means 2 transactions. So, and then for the one-time payments for 2 algos, which made it 13 algos in balances from 11. So if we head over here, we should be able to see our newly accounts balance. So we have about 17. So we've been deducted almost about 5 algos. The 1 algos for the group transaction, and then the 2 for the atomic transaction, which is actually 3 algos. We've been deducted 3 algos from our accounts, our master account address. Actually 4 have been deducted, 4 algos rather. The 1 for the 2-1 accounts, that is 2 algos that was deducted for the group transaction, and then another 2 that was deducted to fund this one for the one-time payment. So it is actually 4 algos that was deducted from this account address, which is the master account. So if we head back here and then go to recurring jobs, so the next execution is going to be in 5 minutes time. So which means another transaction has been made just now. So yes, we can see our balances is now 15 algos. So yes, the group transaction succeeded in working. So we can see that we funded these 2 account addresses via the group or atomic transaction. So at this stage, we have come to the end of this tutorial. We have learned how to create an ASP.NET Core Web API project and integrate an automated payment system on the Algorand network.